Welcome to this session on interfaces in AL at the Dynamic 365 Saturday for Spain. My name is Tobias Fenster and I'll introduce myself in a second. But first of all, thanks a lot for the sponsors who are making this amazing event possible, who are making this happen. So again, thanks a lot. And also thanks a lot for my employer, Cosmo Consult, for again allowing me to sharing the content here and doing this session today. My name, as I said, is Tobias Fenster. I'm the CTO for Cosmo Consult. I'm also a dual Microsoft MVP for business applications. That's why I'm talking today about a feature specific to Business Central and also an MVP for Azure. If you want to get in touch or want to follow what I'm doing, you can find my Twitter handle here. You find the URL of my blog where I'm mostly blogging about Azure and Business Central, business applications in general, and also about Docker. So if you're interested in one of those topics, it might be worth following. And also you can find my LinkedIn profile, so you can get in touch there as well if you want. What I've prepared for today mainly is two parts. The first part is kind of the theory. Why and how do we need interfaces in AI? Why does it matter? How is it implemented? And then we have the demo about actually using the interface. So it will be a lot of hands-on, a lot of Visual Studio code where we will go step by step through the process of defining and using an interface and later even adapting it to a new version. But first of all, a bit about the theory. Why do we need interfaces? And the answer for that at first is componentization. Microsoft has been talking a lot about componentizing the base application. As you know, if you've been following the NAV and Business Central world for the last couple of years. So we have that big monolith, that's the base application, and Microsoft has said that they want to componentize the base application so it's easier to maintain, it's easier to handle and to change. But if you're talking about componentization, then you need to have some way to define a component. Otherwise, there's no componentization if there are no components. For example, it could be a component that is called price calculation, and a component, what it usually does in other programming languages or in programming in general, is it describes the purpose and not the implementation of a component. So it says, what does that particular component do, not how it is implemented. It's kind of the outer surface of a component that is described and defined for a component, but the inner implementation is usually up to the person or the company that is implementing that particular component. But others who want to use the component, they just need to look at the outside. If we have components, then it allows us to think more easily and clearly about the architecture of the solution, about how the different parts and the components that we have interact. If we don't have that, it's always difficult to say, now this is this part, this is that part. If you look at it from this angle, there are different parts. And if you have components, then it's a lot easier because it's very clear what the different parts are and to define the interaction points. The second part is that we can then easily replace a component, either at runtime or at design time. So we can switch implementations very easily. For example, if we get an invoice and we need to bill this to a German customer, then we might need to consider German tax calculation. And if we do this to a Spanish one, then we need to have the tax calculation in Spain or in Denmark or whatever. Or, for example, on an invoice, if it's the standard customer, then we do a standard price calculation. If it's a plus customer, whatever, then we do advanced price calculation because there's something different. And it also allows us to fit a gap that is, or fill a gap that is there currently in the extension model by Microsoft. Because one of the things that you can't do with an extension is you can't replace existing code. And if that code is defined as a component through an interface, then we can very easily replace the whole component and make sure that we are only using the code that we want inside of that component. So that is also filling that one. As you've seen, if we have the same price calculation and it turned from golden to blue, that means that we now have a different price calculation, but we just remove the golden one and plug in the blue one, and now we have completely different code. And the third aspect is extending. So if we, for example, want to have a price calculation with forecast, then it's again very easy because we have a very clear understanding of what that component price calculation is to add additional features like, for example, forecast. So that way it's a lot easier to do that, and we don't need to worry about some events, or is it there, is it not there. We can just clearly define the new parts, make sure we implement the new parts, and then we have those. So when we think about interfaces, it's also interesting to think about decoupling. And the reason for that will be clear in a minute, why we worry about decoupling and how that plays into the componentization story that I just shared with you. But first of all, let's introduce what decoupling is. If you've been working in other programming languages, then the concept might be very familiar to you. It's not that widely known in the Business Central and AL world, but I just want to give a brief introduction to not bore those who already know it. So the base idea is that we have, for example, a report that does sports evaluation, and then we get a basketball evaluation, we get a tennis evaluation, and all that is part of the same report. Now, the first thing that we could do is we move the basketball evaluation out into a specific code unit and the tennis evaluation as well. That means that our code is now going to be moved into those code units. Now that's a bit better because we clearly know what is the basketball code, what is the tennis code, and we have at least not everything in the same place. And while we are there, we can then just say get evaluation as the same method name, because now it's in different code units. But still, those are very much linked together. They are very tightly coupled because they need to call each other. They need to know each other. So from my sports evaluation report, I still need to have a variable basketball code unit. And that one needs to call the get evaluation method on the basketball code unit, and the same for the tennis stuff. So again, those still are very tightly coupled. Why does that matter? Because, for example, if we just remove the tennis evaluation code unit because there is that tight coupling, we will run into problems. It's not that easy to just remove stuff and everything else just works, because there's still a link to that one, and that link now points to nothing. And that's just one example, but just to give you an idea of why tightly coupled components will lead to problems during maintenance. So what we instead want to do is we want to remove the connection entirely. And in order to do that, we introduce something that is an interface. And that interface describes what our different evaluation code units can do. So in our very simple example, all they can do is to give us an evaluation. So the interface only consists of one function, and that's the get evaluation function. We also need to know what implementations are there. So if we want to use them, we need to know that there's a basketball implementation, there's a tennis evaluation, and we will see even more in a couple of minutes. And then we need to have a calling mechanism and an implementation that calls the selection and implements that one. So we're sure that we're calling the basketball evaluation when we want basketball, and we call the tennis evaluation when we want to have tennis. So the connection is basically between the sports evaluation report and the interface. And of course, the basketball and tennis evaluation code units also need to know about the interface. So those are still linked together, but there's no direct link anymore, no direct coupling between the sports evaluation report and the basketball and the tennis evaluation report anymore, because we're now using the interface when calling our implementation code units. And also, when we talk about the implementation list, the basketball and the tennis evaluation code unit need to make sure that the implementation list knows that they are there. It needs to know that it has a basketball and tennis evaluation that's available for the user. And the sports evaluation report just looks at that implementation list when it allows the user to select which one it wants to use. But again, there's no direct connection between them. And the last part of the story is the calling mechanism. So that means that instead of calling the basketball code unit and the tennis code unit directly, as you still can see in the code on the left side, instead it would call the mechanism in between. That one would look at the implementation list, what is there, make some decision based on setup, based on data, based on whatever, which one it wants to use. So that one would return the information that now maybe it's the turn to use the tennis code unit, and that one would then in turn call the tennis evaluation code unit. But again, no direct link between those. And now we can just use the evaluation interface because that is all we need. We only need to worry about the interface, and we just call the method on the interface, and the rest will be handled in the background, as we will see in a minute. Again, why are we doing this? Because, for example, we can just remove the tennis evaluation code unit and we're still fine. Because now the implementation list knows, okay, there's no tennis evaluation anymore. The calling mechanism will never call the tennis evaluation. And because of that, we're just fine. Nothing will break. If you remove the component in that way, then still the others are able to still work. Also, we can replace stuff. So for example, if you want to bring in a new tennis evaluation code unit, that one, of course, will need to implement the interface. So it also will need to have a get evaluation function. It will need to let the implementation list know that it's there now. So the user can actually now select the new tennis evaluation code unit. And the calling mechanism also needs to understand that there is now a new tennis evaluation code unit. Of course, we can also add new functionality. So for example, if someone decides that there now needs to be a soccer evaluation code unit, again, that one needs to implement the interface. It needs to make itself known to the implementation list and to the calling mechanism. But from then on, it's just easily possible to call the soccer evaluation as well. And then we can also think about extending the interface. Now, there are two ways. The first one would be a breaking change. So we would just extend the interface and add a new function. For example, if we not only want to have a textual evaluation, but now we want to also have a graphical evaluation, we could add a function called getGraph, and our evaluation code units would need to implement getGraph. But while we are in that state, in the original state where the implementing code unit only has a get evaluation function, but the interface now got a get graph function, that one would be an error for the compiler. So we wouldn't be able to compile our solution anymore. So this clearly is a breaking change, and I could only solve it by adding that function and then calling that function from the place where I want to use the new functionality. The other way to do is in a non-breaking way would be to not add the getGraph function to the same interface, but instead introduce a new interface. That new interface would have the getGraph function, and because of the way the interface functionality is constructed in AL, we would be able to add this to the evaluation code units as well. But now it doesn't have to, because if the XY evaluation code unit only implements our first interface, then this is still fine. So if we just add the second interface, then there would be no breaking change, there would be no compiler error. And again, I will show you this in a minute, how it actually works. But only if the implementing code unit decides to add that functionality, it would add the second interface and it would add the getGraph functionality, then we could use the feature, but again, there wouldn't be an error if it doesn't do that. Now, from a calling perspective, we would now need to go through the second interface type, so it's a bit more effort on the usage side, but again, it's a non-breaking change, so from a maintenance perspective, that is probably the way that you want to go. So much for the theory. Now I want to dig into the demo and show you how this is actually done. So what we will do is we will define an interface, we will implement an interface, we will create the list and the handler. I will show you how we will use the interface from a different component. We will add a new implementation, which is actually a new extension that we want to create, and then we will extend the interface in a breaking as well as in a non-breaking way. So with that, let's switch to Visual Studio Code to do the actual demo. I have two parts here. I have two projects in a multi-project workspace. The first one is the base implementation, where we will define our interface and some default and base implementations in code units. And then we will add an additional implementation through an additional code unit in a separate extension, so you can see how that works as well. But first, let's work on the base implementation. When we look at the app.json, you can see that this is just standard stuff. We have the regular base application and system application dependencies. You can see that this is platform 16.0 and runtime 5.0. So this is aimed at 2020 release wave 1. But again, nothing special here. The launch.json file also, that one is just aimed at a container that is running somewhere in the cloud. Nothing special in here as well. So with that, I will add a file called interface and implementation.al. As you can see, I'm not too keen on naming conventions. Actually, I don't think it makes sense to worry too much about that, but we will just go with that one for the moment. And of course, there's actual proper naming conventions as well. We will define our interface using the t-interface snippet. As you can see here from the very beginning, we fortunately don't have any IDs anymore, so I don't need to define an object ID for an interface. I just define it, call it sports evaluation. That one actually is following the naming convention by Microsoft, so they have decided to not do an I sports evaluation or something like this, like you would do in C# or Java, but just keep it like a regular object. Same as the others before. You can do blanks. You don't add the type of the object or something like that. So it would just be sports evaluation. Then we have one procedure. Let's call that get evaluation, which is returning text. And that's it. As we've said in the beginning, an interface only defines what can be done using that interface, not how it is implemented. So that one doesn't have any code. It just defines what it would expect from a code unit that wants to implement that particular interface. So with that, we will define the first implementation. And that would be the basketball implementation. Let's remove everything here as we don't need that. And we need to tell that code unit that we expect it to implement the sports evaluation interface. And now the compiler kicks in and says, oh, wait a minute, you want to implement the sports evaluation interface, but that one defines a procedure called get evaluation, but that's not working because you don't have it implemented. As you can see, it says here at the moment no quick fix is available, but fortunately there actually is a quick fix. We just need to enable what's called code actions. So I go to the settings by using Control and comma, and then you go to the extension settings, the AL language extension settings, and then there is a specific setting called enable code actions. Switch that on, and if I now go back here, you can see that it now has a quick fix. I can just click here or use Control and dot, and then I get that quick fix called implement interface, and it will just add the base code for me. So now I have successfully implemented the interface. The warning is gone. All I need to do is add the actual code. So I'll do something like basketball is cool. Germany is very soccer dominated, so I'm not I'm kind of in a minority with my take on sports, but with the big basketball culture in Spain and one of the best ever in tennis also coming from Spain, I'm hoping that I have at least some people who agree with my take, but please don't take it too seriously. Basketball here, then let's add a tennis implementation as well. That one needs a new ID. Let's call it tennis and something like this. Okay, now we have our interface. We have the code units that implement the interface, and we will also want to add a default implementation. So let's add one more. Call it default. Actually, I wanted to switch on the screencast mode so you can see what I'm typing. I'll do it now. Default implements the sports evaluation, and then we provide a default text, and that one is please implement or something like this. Of course, depending on your scenario, you might want to have a default implementation that throws an error, or you know that there is something meaningful going on. So you could also do something like every sport is better than no sport, whatever. So you could add something meaningful, you could add a warning, or you could do an error. That really depends on the situation that you're in. So now we have a default implementation and we have two specific implementations. And what we now need is to have that list of implementations that are available. And that is done in AL using an enum. So I'll use the snippet for that one as well. Again, I need an enum, and that one would be called the sports evaluation provider. And again, we need to tell it which interface we want to use. So that would be the sports evaluation interface as well. As I said, we will want to add an additional implementation in a separate extension as well. So it's important to keep extensible to true. And we've already defined a default implementation. We set it here. So the default implementation for our sports evaluation interface is just the default one. So that means that value 0, which is the default, also just takes that one. We're not adding a specific implementation, as you see in a second, but instead we only add a caption, which would be the empty one. So the default implementation is taken, so that would fall back to the default. If we add an actual value, now we want to, for example, add the basketball implementation here. That would mean that we add an implementation for the sports evaluation interface, and that would be the basketball implementation. We also have the tennis implementation, so let's add one more with a value of 2, of course, and do the tennis implementation. So now we have a list of implementations that are available. We have the implementations, default, and 2 specific ones, and we can take it from there. The only thing that we now need is some way for the user to influence how the decision is made, which implementation is currently used. As I said some time before, this could be some external factor like the price on an invoice or the date. So you have an old implementation that's valid until the last day of 2020, and from January 1st of 21, the new implementation kicks in, or it's random or whatever. In our case, we will just do a setup table. So I've copied that one in here. It's a table with exactly one field, and that references the enum that we've seen before. So in the field selected sports handler, we will have the sports handler that is currently selected, and we want to use that. And to make it easier to change, I will also add a page for that. And that one will just allow us to get access to the selected sports handler field on the selected sports handler table. Nothing more to it, so there's really nothing special. What we also need is a code unit to make that decision for us. So that's a bit more relevant for the interface stuff. So I will implement that one in here step by step. So that would be the sports evaluation management code unit. I don't need those. Instead, I want to have a procedure called a get handler. That one gets passed in a var of the interface type. So we reference our interface sports evaluation, and it's a var because we want to set the value as part of our procedure, and the one who's calling that one from the outside, so it doesn't, it can't be a local one, just gets the implementation that was selected. So we need a record of our setup table. Sports evaluation setup. And we also need our enum. The sports evaluation provider. So with that, we make sure there's nothing happening on our record. And then we just look if we have something in that table. So someone has done the setup already. If yes, then we just take that value as our sports evaluation variable. And it is the selected sports handler that we're looking at. If nothing has been set up, so there's no record in that particular table, then we will fall back to the default. And that's it. So that would be the very easiest way how to make that decision. Again, as I said, that could be way more complicated, but that way, yeah, we create the easiest possible implementation. Now we want to use what we have, so I will create another file, usage, and in that one we will just want to have a very simple page extension for the customer list page. So we have the customer list down here. We don't want to make any layout changes. We just want to add an action, and in that action we want to, of course, call our sports evaluation interface. And to make the decision which code unit we want to use, we also need our management code unit. And that's the sports evaluation management code unit. So we just add a action in the general group. So the action would be that we use the sports evaluation management code unit to get a handler for our for the call. So we pass in the sports evaluation interface variable and we get it back changed. It now points, so to speak, at the code unit that is selected. So if we just use the get evaluation procedure to get the evaluation text, it will show the message. In order to easily find it, let's make it promoted and big. So with that, we should be able to easily find it. So that's all that I want to do in that particular case. So I will just go ahead and compile and publish that one. Let's see, compilation has worked, publishing also has worked. So now we're acquiring a debugger session, and I'll show you the user interface here. So it will take a second to load, but publishing has worked, so that should be fine. Okay, here we are. Let me zoom in a bit. Here we have our action. Could have given it a better name, but every sport is better than no sport. You recognize the default that we have defined, so that one is okay. Now let's say we want to do something specific. We go to the sports evaluation setup page. We see that there is no record yet, so let's create one. Select, for example, the basketball evaluation. Go back here and then call the exact same action again. And now we can see basketball is cool because now we have configured it that way that the handler will return the basketball code unit, and now the basketball code unit code is executed. Just to show you that we can also use the other one. Go back to the sports evaluation setup, change that one to tennis, yes. And if we call the same action again, then now we have tennis is fun with a spelling mistake. Okay, so that's the basis implementation. You've seen how we can implement the interface, how we implement the code unit that is implementing the interface, the enum, and the management code unit. But now let's assume that we want to have an additional implementation. For example, someone else doesn't agree with my selection of basketball and tennis and instead wants to add soccer. So we go to the additional implementation. I've already prepared it, so it has a dependency on our first one. So this is the one where the interface is defined. We of course need that one to know the interface, so we need to take a dependency on that one. But from there on, we can just use it. Nothing else is special in that particular implementation. It only needs to reference the base implementation. So we will add a new file, additional implementation.al. We just create a new code unit. Those are already used, so let's do something like this. And that's going to be the soccer implementation. We again remove everything because we don't need it. Instead, we just use the quick action to implement the interface, and we do something like this because I'm not a fan of soccer. Now we have the additional code unit, but if you remember the theory in the beginning, we also need to let the implementation list know that this is here. Fortunately, we have defined our enum as extendable, so now we can do a extension of the enum. That one is adding the soccer part, and it extends the sports evaluation provider enum that we've defined in the beginning. We will add an additional value of soccer, and that one will have an implementation for the sports evaluation interface, evaluation of type soccer. So that's it. Nothing more that we need to do. So we just define the additional code unit. We define the extension of the enum. And if I again press F5 to run that one, let's see, it's compiled, it has published, it starts. And if we now look at the setup table, or actually the page that is showing us the table, sports evaluation setup over here, then it should now also show soccer. And then we can just, same as before, select it and call it, and we can see the evaluation of soccer. So it's very easy to add an additional implementation of the same, implementing the same interface. So now there's more options for the user. The last thing that I want to show you as part of the demo is how we can add an additional function to the existing interface. And there are, as I said, two options. You can do a breaking change. So that would mean we go to our interface and we just add an additional procedure, get a graph, and it also returns text. And if I save this, you can now see, now I have multiple compiler errors because the basketball code unit doesn't implement the get graph procedure, the tennis code unit doesn't implement it, the default doesn't implement it. And if we look at our additional implementation, the same is true here because the soccer interface doesn't implement it as well. If this is some kind of a mandatory feature of my component, then this might be what I want. So everyone knows where they are broken. It's easy to just follow the compiler errors and look at that ones. So in that case, if that happened to me, I would just go here, say implement interface again. Now I have the get graph method and I'm fine. The other option for that would be to add it as a separate interface. So I'll remove that one for now. Say I want to have an additional interface, sports graph evaluation, and the procedure would be the get graph implementation. Now that way nothing is broken, and I can even add it to the enum as a second implementation. So I can do this. So now I can combine everything in my basketball, in my tennis, in my soccer implementation if I want. But now again, those are broken because they don't implement the sports graph evaluation. What I can do here to again help is to tell that code unit that it also implements the sports graph evaluation. Do the same quick fix that we already know. And say something like no graph here. And now we need to let it know that it also is the default implementation for the new interface, and the syntax for that looks like this. You would say sports graph evaluation equals default as well. So now the default is true for all the cases. You can see that all the compiler errors have gone because now the enum knows that the sports graph evaluation will always point to that particular default implementation as well. I can override that. So if I want to have a specific implementation for basketball as well, I could do something like this. So the sports graph evaluation, I also want to use the basketball implementation. Now I can see an error. Okay, that one doesn't implement the basketball graph evaluation. So let's copy that one here. Go to basketball as well. We now know that one. Implement the interface and exit. Something like this. So now we have implemented it as well. That way we could add a new feature. On the usage side, we would define a interface that is not of type sports evaluation, but of type sports graph evaluation. We would call the getGraph method, and it would then either look at the default implementation because we have defined the default here. So no one is broken. It would just show the default stuff. But if the user has selected the basketball implementation, then it would know that in that case, the sports graph evaluation for basketball also is the basketball code unit, and it would look at that particular implementation and return basketball has fancy logos. So that way we really have two options. We can either choose to break everyone who has implemented our interface to make sure they know about the new functionality, or we can provide meaningful defaults and create new interfaces, and that way don't break anyone, but allow people to pick up new stuff, or if not, just return to the default. So with that, the demo is done. Let's return to the presentation. Now that we've done the demo, let's do a quick recap. Why did we want to go for interfaces? First of all, we want to componentize. That means that we then have decoupling. Why do we want to have decoupling? Because it allows us to easily add new stuff, remove stuff, replace stuff. So we can easily look at components as an easy way to remove the coupling and then be more flexible when we work with components by, again, adding, removing, and replacing. And also, as we've seen, it allows us to easily extend in a breaking or in a non-breaking way. That also means that if you are coming from a position where you want to extend functionality that's already there, or you want to add new functionality, remove or replace it, then it makes sense to first decouple it. And that in turn means that you want to look at componentization, which in AL means that you want to look at interfaces. So both directions are true here, and the answer in both cases is interfaces. How is it done? Again, to quickly recap that one, we have an interface, for example, one that contains two procedures. In that case, we have multiple implementations, basketball, tennis, soccer, whatever, that implements that particular interface. And then when we want to use it, we have the point in the code where we call it. We have the implementation management code unit that in turn has some logic or setup or external influence, like the amount on an invoice, the date on the year, or whatever, that decides which implementation to use. In that particular instance, it returns the golden, so the basketball evaluation implementation to the caller, and the caller still uses the interface variable, the sports evaluation interface variable, but it actually calls the basketball evaluation code. And that way we can, as we've seen, easily replace stuff. We can make changes to the actual wiring of the implementation, but we still use the interface variable. There's no breaking change. The caller doesn't need to worry, but the right code is called. If you want more information, looking at it from a slightly different angle, there is a session on interfaces at the 2020 Wave 1 virtual event for Business Central, where Nikola Kukrika shares his take on interfaces, and I can very much recommend that session. So if you go to that particular link, you will find the recordings there. And if you go to the development section, and then there's a session on interfaces and breaking changes. Again, Nikola Kukrika is sharing the stuff on interfaces, and I want to recommend that one to you because you will get a couple of more information that I didn't share, didn't go into that much detail. With that, I want to thank you for your time. Of course, again, thanks to the sponsors. Thanks for taking part in this amazing event. And I hope you had some fun, you learned something new, and hope you enjoyed that session.